Inheritance. This is Unit 9 of AP Computer Science A, and this is our second lesson, Overridden Methods. The objectives for this lesson that you will is to understand that methods inherited by a subclass can be overwritten in the definition for that subclass, and see an example of a child class in which methods from the parent class are overwritten. Now, first, if you wish a method to perform differently in a subclass from the way it performs in the superclass, you can override the method by typing another implementation in the subclass. A method must have the same return type and method signature, that means parameters and parameter types, as the method that it overrides. A child class may not override a public method from its parent class and make it private. So if it's public in the parent, it cannot be private in the child. If a method is marked final in a parent class, then that method cannot be overridden in a child class. For example, public, final, void run. While the method run may be called within a client program or child class, the method cannot be overridden in a child class. If the original method from the superclass is called in the subclass's version of an overriding method, it is called partial overriding. So if we use super dot and then refer to a method in the parents, it's partial overriding. Okay, you use the keyword super to invoke the method from the superclass. A child class may not override static methods from its parent class. Methods that are private in a parent class may be overridden in the child class. A method that is overridden in at least one subclass is called polymorphic. That means it has multiple meanings. When methods are overloaded and they have different method signatures, the compiler selects the correct version of a method at compile time. Okay, so it figures out at compile time if you've got the correct return type and parameter list. This process is called early binding, aka static binding. Do not confuse the term overload with override. Overload means you've got multiple different methods with the same name but different signatures. The selection process there happens at compile time. Now, when the Java virtual machine determines which version of an overridden polymorphic method to execute at runtime, it uses the type of the actual instantiated object and not the type of the object reference. This determination occurs at runtime and is called late binding, also known as dynamic binding. It is very important that you understand this for the AP exam. Now, here's an example. Person Sally is set to new AP student. So we've got Sally as a person, but going to be created as an AP student. So while Sally can only call person methods without being cast, can be cast and use AP student methods. Now, any methods that Sally wants to use must be in that person class. But when it runs, the Java virtual machine will first check the AP student method. And if the method's found there, it's going to run that one and then go back to the person class. Okay, so notice that having something like Sally.saySomething, this is legal since saySomething is in person. When the program runs, the saySomething in AP student, however, is what gets executed. The compiler just says, Sally is a person, person has saySomething, good. But then when it's running, the late binding occurs. This can get a little bit confusing. Now, from within the subclass, you can specifically call the version of the overridden method by using the keyword super. So notice over here we have the superclass, and it's got a method called A that outputs super A. And then it's got a public method B that calls A, which just is this one. The subclass has public void A, system.out.println sub A. And then C calls super A, so it forces it back to here. This explicitly calls on the super's version of A. Without the word super here, you would have run this one. Now, what will display if the following segments of code are placed in a client class? Pause the video and try these. Okay, did you pause the video? Let's look at this one. Subclass thing is set to new subclass thing.b. It's going to print out sub A. Okay, and again, we're looking at this stuff here. Okay. So, example 2. Subclass thing is set to new subclass and calls thing C. This is going to do super A. Why does this one do sub A? Well, remember B is in, see if I can go back here. B is not in the subclass, but it is in the superclass. But when B runs, it calls on A. And A looks first in the subclass, so it finds the subclass method. About to say function, sorry. Here, remember in C, it was explicitly called. Okay. Now here we have superclass thing is set to new subclass, thing.c. This is illegal. Thing is cloaked as a super, and C is not in the superclass. Okay. Superclass thing, new subclass, thing.a, sub A. Remember, it's cloaked. Okay. It's cloaked as a super, but it's going to look in the sub first. Example 5. Superclass sup is a superclass. Subclass is a subclass. Sub or sup, soup, is set to sub. So now they're going to point to the same thing, but they can't. Why can't they? You've got a top is set to a bottom. I can't do that. I can do a bottom to a top, but I can't do a top to a bottom. Sup can't point to the subclass because it's got more information in it. It's an illegal aliasing. What about this guy? Illegal cloaking. Okay, a subclass can't be cloaked as a superclass. It's got to be the other way around. What about 7? Superclass is set to new subclass. Okay, so I'm going to restrict it so it can only call directly the things in the superclass, but it's really a subclass. But then I can cast it as a subclass and call method C. What about this guy? If it's a superclass, can I cast it as a subclass? No, that's illegal casting. Okay. Take a moment, pause the video, and jot down notes so that you know exactly how each one of these work. Make notes on why, so you can go back and refer to it, especially after tests and quizzes. Constructors and inheritance. Constructors of a parent class are not inherited by a child class. Therefore, a child class must define its own constructors, since they are not inherited. However, you can invoke a constructor of a parent class with the statement super. If you want to call the parent class's constructor, say that 3 times, you must do so on the first line of the child class constructor. So here we have our superclass. It's got a num. Here's the default constructor. Here is the parameter constructor. Our subclass extends superclass. Okay? And this has an age. Now, public class super says, go call this guy. So now num gets 10, and then age gets 5. Here, system.out.println, other subconstructor. Age is set to an amount. I can instantiate or initialize the specific amount I want. All right. Now, for this example, I think I left out a whole line here. Yep. Let's look at these examples and see what they do. Example 1, some class thing is set to new subclass. Super constructor subconstructor gets called. Now, what about if we declare something as a superclass and instantiate it as a new subclass? Super constructor subconstructor. Okay. How about subclass thing is set to new subclass 8? Well, this is going to call superconstructor and then other subconstructor. The superconstructor, notice it got called no matter what. Let's go back here and take a quick look. Here where I pass in an amount, this superclass got called automatically. This called it explicitly. Okay? Java automatically calls the superclass default constructor, but it's much better coding style to do it explicitly. Right? So notice all of these went to the superconstructor first and then to the subconstructor. This last one actually went to the other or the parameter constructor. Now, so far, what do we know? Well, we're going to look at a class of car. On the next page or next slide is a class that represents a type of car, a hybrid car. It also summarizes all the things we've gone over so far in this unit. It's got a class car. It's got miles per gallon and gas. So how many miles it gets for every gallon, the amount of gas in the car in gallons. Then public car, we can pass it the miles per gallon and the gas. Sorry about that. I want to change that. It should be M. So miles per gallon gets M. Gas gets the G. Now, we're going to drive car MI miles or some distance less than that if it runs out of gas. Returns true if the car drives MI miles, false otherwise. So, if gas times miles per gallon is less than miles, gas MPG is how many miles the car can still travel. Gas is set to 0, return false. Else, gas minus equals miles divided by MPG, return true. So we're going to find out, can we go that far? And notice you pass in MI for the miles. And that ends the method. This is what a car does. Now let's look at the hybrid. Okay, so here's our class for our hybrid model. And the big thing here is notice, with a hybrid, it's also going to have an MPG and a gas. But we never rewrite instance variables that a superclass already has defined. If it's a car, it has MPG and gas. Hybrid, all we want in terms of instance variables are those things that are specific to hybrid. So that's miles per electricity and the amount of electricity. Our constructor, okay, we always want a constructor. We can pass it M, G, MPE, and E. Notice that it will call super MG. So it's going to call the superclass constructor, setting the miles and the gallons. So I don't do that here. I can't touch those instance variables. I have to go through modifiers. So don't try to assign a private field of a superclass. The super command should take care of that. I do want to assign my miles per electricity and my electricity. Then Boolean drive double mile. I've got to override this because it's not based solely on gas. It's based on gas and electric. But I still need to know, can I drive this many miles? So here, if electricity times the miles per electricity is greater than or equal to miles, I can reduce off the electricity and return true. Else, I can do the electricity, set electricity 0, return super.drive miles. What am I doing here? Well, this, see if I can, up here, this right here said I can go my entire way, change this to a pen. I can do this whole thing all electric. Otherwise, I might have to do electric, okay? So this means I'm going to use up all my electricity, and then can gas make it? But notice that I've got my miles, okay? I've already subtracted off. I've dropped down my miles. I've said electricity is going to get me 20 miles. I'm going to call super, which just goes to the car and checks the gas part and says, can the gas handle this many miles? And it's going to be true or false. Okay? So whatever super.drive responds with the miles, that's what's going to get returned at the very end. And then this ends the method. So this is a partially overridden method. This is a case where I want to do something different, but then I don't need to rewrite the gas part. It's already in existence, so I'm going to just use it. Now, we're going to look at a Pokemon problem. In your notes is the Pokemon class below. What I want you to do is pause the video, take some time, and read it over so you understand how it works. You're going to have a catch rate, an attack power, a weight, and a level. Pokemon, you've got your constructors, you've got your accessors, and you've got your modifiers. Okay? And then you've got some other functions like level up and cry. Pause the video and look at these. Make sure you understand how they work. Okay, now what you want to do is, again, pause the video, because in class we'll be pausing to give everybody time to do this. And the idea is go back, look in your notes, see if you can figure out how to implement a Pikachu class that is a Pokemon. It should have a new instance variable, a Boolean that keeps track of whether Pikachu has the light ball or not. This affects the attack power of the Pikachu. This class should have one constructor with 3 parameters. The weight is an int of the Pikachu, and the level is an int of the Pikachu, and whether the Pikachu holds the light ball or not. So pause this video now and write your public class Pikachu extends Pokemon. Now notice I've covered up mine, and on the left here are the things that you have to do. The methods of the class should implement the following characteristics by overriding methods inherited from the Pokemon class. Let's go ahead and pause. Okay, let's take a look. The catch rate of a Pikachu should be half the rate of a standard Pokemon. So if we look back here, okay, we have a catch rate. That's a private value. But we can actually set the catch rate. Okay, and catch rate is equal to R, so we're going to pass it in some value. So when we go to write this, okay, there's our light ball, there's our constructor, but our catch rate, we're simply going to set catch rate to get catch rate divided by 2. It's going to be half. So this get catch rate will get the catch rate of the super class, or the Pokemon class, and divide it by 2. The attack power should be the same as a normal Pokemon, except for 2 things. A Pikachu weighing over 50 pounds loses 5 points in attack, and a Pikachu with a light ball doubles its attack power. So let's first go. If weight is more than 50, set attack power to get a power minus 5. This get power is going to go to our super class. You could put super.get attack power if you wanted. If light ball, set attack power to get attack power times 2. Again, remember your attack power, the only variable you have access to here is light bulb. The others you must use accessors and modifiers from the parent. Now, when a Pikachu levels up, it should level up like a normal Pokemon, but it should gain a little weight and then print out a celebratory message that includes the Pikachu's current level. Let's look. Public void, level up, super.level up. So however I want to level up, I want to go to the super one and do it. Then I need to gain weight. So it's going to level up just like any other Pokemon, but then it's also going to gain weight. And here's your celebratory message. Finally, the cry of the Pikachu should be changed to have the Pikachu's name in it. So it should say Pikachu instead of Pokemon. So this is an overridden method. Were you successful? If you need to, pause the video, copy down this, and compare it. And again, there's a spot in your notes where you can write this down. You have all of this verbiage here, so you can use your arrows to point to the different parts of the code. All right, the object superclass. All classes in Java extend the object class, explicitly or implicitly. Public class stock extends object. All objects inherit the following methods: public string to string, public boolean equals object other. Okay, so string, default implementation, class at memory location. The boolean returns true if this object is equal to another. The default implementation only checks for reference equality, meaning they're pointing to the same thing. If you want to actually check values, you have to write that. So let's take a look at this first one. Public class point, private int x and y, public point, int the x, the y, public string to string. If I have point A is set to new point 3, 4, I system.out.println a.toString, print 3, 4. System.out.println a outputs 3, 4. By default, it will go to this toString method. If there is none, it will spit out a memory location. Okay, so if there is none, right, there's no toString, it will spit out the memory location. This actually has a memory location, or has a toString method. I've got name. It's got a private variable string and public, or I can set the string. So here, name first is set to new name Matthew. System.out.println first.toString. First.toString, name, or the output is name at blah, 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 blah at D674E. And here, first. Okay. Now, the equals method. The equals method should check if two objects contain the same current state information. Works for most types we've discussed, such as string, integer, double, etc. Other types may only use reference equality for the default. It checks if two objects are actually the same. Changing one affects the other. That's the equal sign. So here, if I have a point and I declare it a 7-2, this is what gets set up in memory. Point P2, this gets set up in memory. I declare and instantiate P3 and set it to P2. That means it's going to point to the same place in memory. So is P1 equal to P2? No, because this is P1 and this is P2, and they're pointing to two different things. So therefore, this is, whoops, if I can spell, is false. Because these two are not pointing to the same thing. P2 equal to P3. This, on the other hand, is true. The memory addresses are the same. P1 dot equals P2. That's true. And then P2 dot equals P3. That also is true. The equals, okay, is checking to see if x and the other x are equal to each other. And since they're ints, it'll do exactly what you think. Now, for a custom class, you are given, you should assume that equals is going off of reference only, this guy, okay, where P1 and P2 are not equal, unless you have the equals method written out. And that concludes Overridden Methods, Unit 9 in AP Computer Science A.